Thank you very much. I mean, Blanca told me that we're going to have a track that's called Architecture Through Different Lenses. I couldn't say no, because I think architecture has actually a lot of different lenses and different dimensions. So I felt that this is a great opportunity to reflect a little bit on what does it actually mean to be an architect. And my view on this is really, it's not anything on your business card. I've met great architects whose title is an architect, and I met people who have the word on the business card where I would say, in my view, they're not such great architects. So it's really, yeah, it happens. So it's really a way of thinking, a way of, I would say, a lifestyle almost. And I've been in many different organizations that also had different views of what architects are. So I used to be a chief architect, which sounds very ominous, whatever that is. But I've also been in organizations that proudly proclaim they have no architects, but they still had an architecture. So it's kind of interesting to be an architect and to really get to the essence of what that really means. So here's my attempt, and I warn right up front, I don't have a single definition, but I have different lenses that I think help you reflect on how you can be effective and valuable as an architect. And here's my first important statement about this, right? Often architects are seen as these people who should make all the decisions. They're a little bit older than everybody else, maybe get paid a little bit more, they're a little bit wiser, or at least they look wiser, right? And they should sort of be making all the decisions for everybody else, so everything goes well. I think being that smart and that wise is really, really hard. I wouldn't definitely claim that of myself. And B, why should one person make all the decisions, right? How can one person be smarter than everybody else? And especially if they don't work on the project or they don't code day to day, how come that these people would be better equipped to make the decisions? So I'm very adamant about saying is you should not be the smartest person in the room or the smartest person in the team who sort of tells everybody else what to do. Your job is really to make the other people a little bit smarter, to help them come to better decisions, to look at their problems through different lenses, understand impacts, trade-offs. That is really your role as an architect. You're sort of an IQ amplifier for everyone else. And that, I think, is a great way to start looking at what architects actually do. So I'm not going to read those out because we're going to cover them one by one. And these are sort of the different lenses that I talked about of what I think if you find yourself assuming the role of an architect, knowing that you're an IQ amplifier, those are the things that you can do to accomplish that. So let's start with the levels. I wrote a book called The Architect Elevator. That's sort of a little bit my pitch, and that is about connecting different levels of the organization. And the opening question for that is really, which architect is the most valuable one? Right? And it's a trick question. You can get people pretty riled up. Some people say, well, the chief architect, obviously, right, is the chief. They must be the most valuable or most important architect. And then you can easily make the counter argument to say, no, it's like the ivory tower people, all they do is draw pictures. It's the folks who are most hands-on, make decisions, implement things, get the software to work reliably, scalably, they are more valuable. In my view, it's asking the slightly wrong question, or it's thinking about the question from a wrong perspective. I find the most valuable person, neither the one at the top, nor the one only at the bottom, but the people who can connect these different levels. So a maybe chief architect or somebody who does draw pictures, does draw a lot of pictures, if these pictures trickle down and help you make better decisions, that is very valuable. If they don't, if they just sit in the penthouse, probably not. And vice versa, right? If you're really good at systems engineering, you might be a great developer, but none of that ever connects to the success of the organization or the application as a whole, then also your value might not be as large. So it's not about which level you sit at, but it's about how many different floors you can cover. And that is what the architect elevator is all about. I encourage folks to ride the elevator and not get stuck at a single level. And why is this so important? Because organizations tend to have many different levels, right? It's division of labor. Sometimes it's legal considerations, right? Like an organization isn't all one team. There's leadership, there's CEOs, there's boards, right? There's development teams, sometimes things are outsourced, right? There's all these different layers. And that can lead to some issues. Like a very common situation you have is the penthouse up there, the leadership lives in the illusion that in IT everything is fantastic. It's like, hey, we have blockchain and Gen AI, right? How much better could it be, right? And down at the bottom, the developers feel a lot of freedom because management has no idea anyhow what they're doing. It's like, great, right? We told them we're working on blockchain, but we're actually writing this open source project, right? Life is really good. The reason this can work is because there's this isolation layer in the middle, and that's called middle management. So this is an interesting architecture. This is a loosely coupled architecture. However, it's not the kind of loose coupling that the organization would normally wish for, right? Obviously, something is wrong here. This is a dangerous disconnect. If the people build things that don't contribute to the strategy, and the folks who make the strategy are not connected to the reality, that doesn't go well. So that is the problem we try to fix when we say the valuable architects are the ones who can make that kind of connection. Now, as architects, we like models, and that was one of the items on the list. So if you want to drill deeper into why this going across layers is so important, we can use a model. This is an architecture pattern, right? It's one of the most basic architecture patterns. Everybody knows layering, right? You divide things in layers. And why do we divide things in layers? Because it has some obvious advantages. I already mentioned, you have separation of concerns. You can hide and abstract details in one layer. You have nice dependencies and interfaces, and that affords you things like replaceability. It's easy to take one layer out and put another one in. Architecture is the business of trade-offs, so where there's a plus, there's also a minus. We also know that too many layers can bring overhead, and this can be runtime overhead, right? If all these layers are connected by sort of XML protocol, right, you end up doing a lot of parsing and marshalling and garbage collection, right? You might have latency. You might have things like change propagation. People know this, right? If you have an application that is structured in the front end, the back end for front end, the API layer, the business logic layer, and the database layer, and you want to add one field to your screen, what do you end up doing, right? You end it to the user interface layer, the backend for front-end layer, the API layer, the business logic layer, and the database layer. That's what's called change propagation. So the changes tend to run vertically through these kind of things, and if you have too many layers, you're not sure what goes into which layer actually, and that has its own complexity. Now, two things we learn here. The first thing is, the way I just described this, I didn't say whether this is a technical system or an organizational system. So the front-end example aside, right? Like all these things apply to organizations as well as to technical system. Replaceability, what is that called? Outsourcing, right? You take one layer out of the organization and put it somewhere else. These effects apply to both technical systems and organizational systems. So what you learn here as a technical architect, you actually understand a lot more about how organizations work than you might have thought, because all these considerations apply to organizations as well. If you have a lot of change in the organization, all this layering is gonna be in the way. The second one, I already gave a hint about that. The second one, if you look very hard, the things on the left-hand side and the things on the right-hand side are slightly different. They come out of a different bucket, so to speak. And you have to sort of squint pretty hard. So the left-hand side, those are more structural considerations, right? Interfaces, dependencies, abstractions, right? That describes the structure of the system. So the benefits are largely structural. The right-hand side uses slightly different words, so like changes, optimization, latency, overhead. Those are more runtime-y kind of, they're more like performance operational kind of words on the right-hand side, right? This is how the system behaves. So what you realize here, and this is the second major insight we have, is that this layering works well if something is slow-moving, because the structural things on the left benefit, or you benefit from them. Versus if things become fast-moving, the things on the right-hand side who are more dynamic, operational in nature, they will weigh more heavily. And this explains why organizations became this way, because they made for an environment that is not fast changing, but we all know that is not the environment we are in today. So it's not like this model was wrong. It was made for a different context. It was made for a world with a low rate of change. We don't live in a world with a low rate of change. So as architects, we can start having a lot of insight by using these models and actually realize that the organizational system and the technical system actually have a lot of similarity. So basically, as software and IT architects, you are also already organizational architects, right? And this is what I pitch riding the elevator, and many of the topics today relate back to this, right? Where you make this connection, organization and technology, one cannot exist without the other. Careful, right? Riding the elevator up doesn't mean dumbing things down. You're talking to some of the smartest people in the organization, right? They run the whole company, right? They didn't get there by not knowing anything. They might not know what a Helm chart is, and that's totally fine because that's not their job. So don't dumb things down, but convey meaningful details that help them make better decisions. So the architect elevator is not about telling completely different stories to different people, but it's about making the connection between the different levels. So the story has to be connected. Here's a simple example that I've been using for a long time. So let's say you come out of the engine room, right? And you talk about high levels automation, you're in the cloud, speed, velocity, feedback cycles, DevOps, agile, right? That's the kind of stuff you talk about. And you tell, or that we get excited about. And then you go tell this to a CIO, right? Or the head of IT. And they say, oh, this is really nice, but what my boss wants, which might be the CEO, is, well, they don't want to be in the newspaper, right? So security is number one, right? We don't want to have a breach. Nobody pays for IT that's not running, so availability is high on my agenda, and please don't spend too much money, right? And you can have a sort of odd discussion about which one is better between the two. Now, the maneuver you want to do, the architect elevator maneuver, is to show that the things on the left actually get you the things on the right. So the stuff out of the engine room that you're excited about actually gives the CIO exactly the things that they're excited about, right? How are you gonna get security? If you have lack of automation and you do manual patching, I guarantee you that stuff is not gonna be up to the latest versions. It's gonna have some exploits. So automation is critically important. Doing this quickly, right? Having feedback and observability and knowing when you have anomalies, right? Detection, right? Those are key mechanisms. Same thing. Availability, classically you get availability with standbys. Standbys are expensive, right? You spend double the hardware to get like 1% more of uptime or 0.5%, right? So how can you be cost effective and highly available? Through high levels of automation and elasticity, and the faster you can spool up new resources, the tighter you can run, basically, right? When the spikes hit, right, then you can scale up faster, so that means you can run closer to the limit. So that's what the architect elevator is about. It's not repeating the stuff on the left 12 times until the guys on the right finally give up. It's about making this connection and explaining why this stuff is actually getting you the stuff from the right-hand side. So a couple of takeaways from the first part here is it's really important. What I like to do to make these connections, I like to use a lot of metaphors. I'm somewhat famous for using car metaphors for everything. Pick whatever you like. Ideally, you pick a metaphor from the business that you're in. And I have an example later. I used to work in financial services. So if you can use metaphors and language from your business, you will win immensely with the upper levels of the elevator. And what you're doing by using metaphors is you're inviting your audience into the thought process. Let's be honest, when we talk about our techno mumbo jumbo with leadership, the real translation is trust me, right? You say like, oh, we need to be like, EKS, Fargate, this automation, containers, container orchestration, loosely coupled, event-driven, blah, 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 right? Please give me $5 million. Really what you told them is trust me, right? Because they have no idea. So then they might trust you, then good for you, but if they don't, right, they feel a little bit uneasy. So using metaphors invites them into the decision process, allows them to think with you. Now there's people who don't want the leadership to think too much, right? Wouldn't it be just nice if they just put the stamp, right, on the purchase order and off you go? Wouldn't that be convenient? Maybe yes, but that is not in the purpose of the organization. You're underutilizing your organization's mental resources. You have smart people sitting there and you're not inviting them into this thinking process. That is waste, right? That is not a good thing to do for the organization. So metaphors, examples, using clear language, those are the things that forge that kind of connection. Pictures. I joked in the beginning, oh, if the architects do nothing but draw pictures, right, they might have a fancy title, but they might not be as valuable. Correct myself a tiny bit. Drawing pictures is actually valuable as long as they connect to something. Now, when you search, and I just did this morning, if you search for like IT architecture diagram, this stuff comes up. Boxes and lines. Some of you guys know my preference for lines. So I'm happy that some of these actually have lines, right? I often said architecture without lines is not architecture. But fundamentally, you know, they're these kind of boxes and lines kind of things. What do real famous architects? I know the analogy is always a little risky, but let's say, what do real building architects draw? They draw sketches. They don't draw the blueprints, right? I'm talking the famous guys. This is like Frank Gehry here, right? The famous guys. They sketch. And why do they sketch? Because they want to capture the essence. They're abstracting things away. They're looking at the big picture. And you might think like, oh, I could have drawn that. And the short answer is, no, you could not have, right? There's much more behind here. You can maybe copy it, right? But you know, there's much more behind this than it seems. And that's the power of abstraction, the power of emphasis, right? They emphasize certain elements. They also incorporated the context. This thing is a little bit sort of horizontal, and that has a reason, because this is the Guggenheim Museum in Bilbao, Spain. This is by the waterfront, and if my sort of Photoshop skills were a little bit better, I can probably get this to match up. So these are not ivory tower kind of things that are detached from reality, but they actually make the core decisions, sort of the gestalt, like we like to say, of the thing that is going to be built, and some of the key trade-offs that need to be made. So think about it. There's many folks who can draw the blueprints. As an architect, give yourself the liberty to sketch to something that makes a certain emphasis, that uses a certain lens, right? Like a sketch has a very specific lens to it. That's our topic for today. And that is most nicely done with a sketch. So architects draw pictures, but not necessarily boxes and lines. Architects can sketch. One of my favorite maneuvers for architects is that we also see more dimensions. And that really changes discussions that people have. Because you remember like IQ amplifier, right? You make everybody else a little bit smarter. And I don't mean they're like dumber before, but like smarter in the way they look at the problem. The fancy word I say of this, you open up the problem and solution space, right, in a way for them, right? That's how they get smarter at tackling the problem. Because you will have situations like this. Two people look at a problem from one dimension, and they can argue until the cows come home, right? One person will say, oh, this is a circle. And the other person is like, where do you live, right? It's like, you know, you have no idea. This is a rectangle. And the other said, no, this is circle rectangle. If this is at the pub, it might be entertaining. If it's at the workplace, this isn't very productive, right? They will go back and forth. And you will have these things. People say, oh, we need to accelerate the delivery schedule. And the other people say, oh, but we need testing. We can't compromise the quality. And then when I schedule testing, right? They go back and forth, and this is basically just a different flavor of, you know, circle versus rectangle. So as an architect, you can put the third dimension on this and test, you know, speed versus quality is a perfect example, right? Why don't you automate your tests? Why don't you test earlier and incrementally, right? Those are the things that come from seeing more dimensions, so it's no longer left or right. So seeing more dimensions is a very, very powerful maneuver to sort of amplify the collective IQ. I do this quite a lot. So I gave a talk, actually yesterday was a cloud event, AWS, right? We talk about lock-in switching costs. It's sort of my favorite topic because it's every cloud vendor's unfavorite topic, so I always like to tackle the special things. So we talked about, right, how difficult is it to move workloads from one cloud to another. And generally, people have this idea of a single dimension. They say, oh, if I want to use serverless and all the great cloud stuff and all the managed services, that's really great from an architecture perspective. Ooh, but it's really bad from a sort of lock-in perspective, right? And as long as you think about this on one dimension, there's never a happy place, right? Like people argue, oh, should I be here? Can I use this, right? Basically, as long as it's left or right, and you have some evils on the left and some evils on the right, you have never a happy place. So one of the key maneuvers I do there is think about this in more dimensions. And again, there's multiple lenses of more dimensions here to make it more interesting. The one is lock-in or switching cost is a liability, right? It's like sort of a possible future cost that you carry, right? If I use a certain platform and switching to the other side costs me £100,000 to do that, and maybe I have a 5% chance that I need to do this, you carry a £5,000 liability. That's math, right? But at the same time, you might get benefit, right? You get serverless architectures, you get managed services, less operational toil, so you have a benefit against this. So you can talk about two dimensions, right? How much do I get out of having the switching cost, and how high is the switching cost, right? Now, of course, ideal is, if I get all the utility but low switching cost, but I might also consider that, hey, this is actually not a bad trade-off. If I carry this £5,000 liability, I gain much more than £5,000 in the short term. The nice thing about these decision models is, and this is one of my sort of fundamentals when I talk with customers, is I rarely tell people what to do. And oddly, that is initially unpopular because people come to you to get an answer. Just give me the answer. I'm like, how can I give you an answer? Because I don't know your situation as well, your constraints, what you really want to do, right? It's your company, not mine. And many people like to do this. Oh, just do X, Y, Z. I'm like, life is not that simple, or at least the life of an IT architect is not that simple. So what I do instead is give people a model to think about their problem in a better way, right? IQ booster here, and then you decide based on this model. That is something I much more like to do because at the end of the day, they know better, but I can give them a better model to come to a better decision rather than just giving them a quick and easy answer. Our life is, our world is too complicated for quick and easy answers. So that's why these models are very nice. I have this in one of my other books, Cloud Strategy, where, again, I play this dimension maneuver, where I say the switching cost story is not a single thing. People say, ooh, I'm locked in. That sounds like binary, like, the lock is closed or it's open, and it sounds like it's a single thing. Both are wrong. It's not binary, it's a cost, right? That cost can be higher or lower, and it has many different dimensions. Changing anything has a cost. Not just a vendor, also changing a product. Changing a version has a cost. My favorite example I always joke about from AWS perspective, sort of my favorite, least favorite feature is extended version support on EKS, so the managed Kubernetes, right? We now recently launched that you can have older versions. Why, as an architect, do I not like that feature? Well, because you should be on the latest version, right? Why do you need to be running on an old version? You don't get the features, you might have other issues, right? Why are you not on the latest version? Well, the answer is very easy. Version upgrades also have a switching cost. And now you're working on a managed open source project, right? There's no vendor locked in. This is managed for you, right? But still going from one version to another isn't free, obviously, because a lot of customers use this. So there you have a switching cost. So breaking this down makes you think about these things very, very differently, right? So some people will come to you and say, oh, don't worry about switching costs. That's, of course, BS, right? You should think about it, but you should think about it in a multidimensional model so that your problem and solution space is much more nuanced, right? Maybe I want to make my version upgrades cheaper so that I can be in the latest version. Maybe that's in the near term more important for me than needing to go from vendor A to B or product or architecture A to B. Again, nobody says what you should be doing, but you get a better view on what your options are. So here's this left versus right, this one-dimensional thinking. And this is a little bit out of sort of the penthouse, like IT strategy, where Every CIO, every IT leader I talk to pretty much lives in this, I call it between a rock and a hard place, right? They live on this sort of scale of unhappiness, where on the one hand side, they're supposed to harmonize, get complexity down, get cost down, right? That's why as a developer, when you say, I want to have database X, some evil person that's usually called enterprise architect comes and says, no, in our environment, we don't use database X, we standardize on database Y. And you're like, why is that, right? So that's harmonization, complexity reduction, cost reduction, economies of scale, because maybe vendor Y gives us a discount if you only use vendor Y database, but you like vendor X database better, and the whole thing isn't very happy. And then the business comes and say like, oh, competitive field, fast-moving, agility, innovation, right? We need to drive and go to market. And the problem is, well, I can do innovation with database X, but you just told me I can't have, right? So, again, if this is one dimension, if this is a linear scale, there is no happy place, right? People can like argue about where they want to be, but they're never happy. So the thing you can do as an architect, if you see more dimensions, you can bust through this stuff. And in this case, I actually written a whole book. Don't want to talk about the books too much here, right? But in this case, it was a topic where really a whole book and a whole industry in a way came out of platforms do this. Platforms harmonize and standardize, but don't stifle innovation. They actually boost innovation. And we know this not just from IT. I mentioned car metaphors. Car manufacturers in the 70s started using a platform model, right? They started realizing that all the heavy-duty engineering they're doing, they should put that in a common car platform. Volkswagen and many others did this, and then they can put different models on top. And the interesting thing is by standardizing on the platform, they didn't reduce the variety and the innovation, they increased the innovation. They made many more models. They could have more diversity by standardizing, right? And that thought relies on seeing this as not a single dimension. BMW is a great example. Like in the 70s, they used to have 3 car models, 3, 5, 7 series. And now I didn't count, it's like 25 or 30 models, right? There's a 1, 2, 3, 4, 5, 6, 7, 8. Then there's an X for everything, and then the electrics and the whatever they all have, the performance models, right? The minis, right? That's BMW. So they have like 30 models. That would be impossible without busting through this one-dimensional thinking. They wouldn't be able to have that product diversity. And people can do that for cars, that are made from metal and put together. We can definitely also do that for software, right? It should be easier for us to solve that than for them. So this idea of turning one dimension into 2 and having the combination actually applies to many things. I mentioned quality and speed, right? Automated testing gives this to us. Platforms give us standardization, harmonization, but still innovation. Customization and cost. Like say you have an e-commerce marketplace. With AI, you can give every customer a customized experience. Doesn't cost you hardly anything. I work on serverless, right? It used to be you make a prototype and then you throw it away. In serverless, your prototype will actually scale to like 1,000 TPS. Openness and monetization, right? How can you make money if something is shared? Well, look at all the open source IPOs, right? So there's many ways that these things that were perceived, you can only have one or the other, you can have both. And that is a very powerful architect maneuver. And that comes from seeing that this is not one dimension left or right, that these are different dimensions. Next one, I mentioned metaphors. So options is one of those metaphors. And we used to work in insurance, right? It's a metaphor that comes out of the financial space. And I want to explain what I mean by that because I think it's a very powerful way to understand how as an architect you make decisions. So let's stay with this sort of innovation versus standardization topic for a little bit, right? The platform story. So let's say here you want to have some diversity, right? Remember, so harmonization and diversity are sort of at the opposite ends, some people think. We don't think so. So here's some diversity, right? You have some developers who prefer the stuff on the left and some other developers who prefer the stuff on the right. And you can make all sorts of jokes about who's here, who is there, right? But the idea is, how do you get this to work? Well, we IT architects, software architects, we didn't know the answer. It's very easy, right? You make standard APIs, interfaces, you connect them with protocols like OAuth, right? JSON, etc., right? That's how you get over this problem, right? Microservices architecture, very, very clear. We do this all the time. What is the maneuver you have done here? The maneuver you've done, you placed some harmonization, right? Remember that word. The interfaces are common. You locked those down. So you gave up some options, right? This is not protobuf, or maybe you pick protobuf, right? But you pick an authorization protocol, you pick a transport, you pick a data representation, you lock some things down in order to gain other options. Like you have more options now. You can code in Java, C#, Python, right, whatever you have. So this is a very interesting maneuver. It goes back to the platforms, right? You standardize some things and give up the options there so you don't have all possible protocols, but because you do that, you enable diversity somewhere else. That's like buying and selling options, right? You give away some, but you gain other options. And these options are valuable. So the option to use another language is valuable. The option to move your workload to another provider is also valuable. Having the option to scale up your system, right? The option to add hardware or capacity, all these options are highly valuable. And that's been mathematically proven. Yeah, the quiz comes later. One thing we learn here, for people in the financial world, this is as obvious as Kubernetes and Helm charts, right? So reflect a little bit when you talk about your IT mumbo jumbo, this is what they are seeing, right? So now you're feeling the pain from the other perspective, right? To them, this is totally obvious, right? This is options pricing. Black-Scholes, they got a Nobel Prize economics for it, so, right, a little bit more advanced. But this basically shows that having an option is always valuable. Right? Because if you can do something later on, if you can defer a decision that has value. I just talked about capacity, right? In the cloud, you have elastic infrastructure and scale-out architecture, so that buys you the option to add capacity later. And that is a valuable option to have. Now there comes a very interesting insight, which derives immediately from this formula, is the little sigma over there, and that is the volatility. These options are more valuable the more unpredictable things are. Let's stick with this capacity management example, right? If I build something for 5 users, and it's always be 5 users unless one calls in sick and then it's 4, right? Do I need this scale-out elastic hardware thing? Probably not, right? Because I just have 1 VM and life is good. If I build a mobile app or launch an e-commerce store or something, I don't know if I have 100 users, 1,000 users, or 100,000 users, then that option becomes very valuable. So the more uncertainty there is, the more volatility there is, the more valuable these options become. So that's the power of using these metaphors, because now you're not just making the intellectual argument, it's actually mathematically proven. It's like right in there. Every financial person will tell you that that is true. That's the power of metaphor. Like if you tell people like architecture is like options, you know, and you say like, hey, uncertainty increases the price of the options, they will say bingo, right? And I have that very experience. In financial services, other industry, pick a different metaphor. Something else falls out of it. So if architecture sells options, and the options are valuable the higher the level of uncertainty is, well, let's park that thought. There's another approach that starts with A that we use frequently, which is also good at dealing with uncertainty. And that is agile, right? If you know everything and nothing ever changes, you don't need to be very agile. You write it down, you build it, you're done. So agile fuels of uncertainty, of change, of volatility. And so does architecture, we just realized, right? So when anybody comes to you in the future and says, oh, the architect, right? That's really nice, you're doing this thing, but I'm over here, I'm agile, I don't need so much of this. You can say, you know, interesting, you should say that, right? Because I deal with uncertainty, and so do you. So architecture and agility actually live in the same universe. They have the same kind of benefit. I have car metaphor, right? Agile is the steering wheel and architecture is the gas pedal, or the engine, right? Architecture makes sure you keep moving, and agile makes sure you're moving the right direction, right? It's the perfect combination. There's absolutely no contradiction here. Both live off uncertainty. If you know everything and nothing changes, you don't need a great architecture, right? Because you get it to work somehow, right? Fine, you know, you're done. And you don't need agile. Not the world we live in. So that's why you actually need both, right? Very different view on agile and architecture. They are friends, not foe. Zooming in and zooming out. Seeing things, right? The elevator, right? Things from the top look a little bit different than from the bottom. And it's not just sort of a zoom on the camera. It's really our world looks very different at different levels, right? It's like a fractal world that we have. And understanding that is very valuable to ride this elevator. An example I often give, like some years ago, there was this statistic about if you get XYZ cloud provider certification, here's the salary you can command, right? So here's how much this thing is worth. And then all the folks sort of at the zoomed in level in the engine room is like, oh, I should get the certification of vendor X because that pays the most, right? So I should run over there. If you go a few levels up, if you zoom out a little bit, you come to very different conclusions. If an IT leader looks at this and says, oh, this skill set is most expensive, that means it's hardest to get. That means that technology choice is probably not the one I want to make because I paint myself in a corner because I can't get the people. And if I can get them, I need to pay them a lot more money. So they come to opposite conclusions based on the same information. No, not one is wrong, one is right, but you need to understand that thinking about these topics from different levels leads you to very different conclusions. And that's the fractal nature. It's not like grouping 3 boxes into 1 box kind of thing, right? It is really you see different things and you come to different conclusions. Now, here are some boxes and some lines, right? This is also an exercise of zooming out. Too many people look at each box in a system individually. By zooming out, you look at the system as a whole. And I can at least tell from my experience, 9 times out of 10, the problems are not in A, B, C, or D. The problems are always in between. Assumptions that somebody made, dynamic behavior, one system overloads the other one, right? Like all this kind of stuff, right? The lines are actually a lot more cause of trouble than the boxes, and that you get by zooming out. Also by zooming out, you realize that how a system is put together defines the essential properties. Do you think the left and the right has different characteristics? It's made from the same components, just wired together a little differently. The answer is, of course, they have almost exactly the opposite characteristics. The left-hand side, layering, we already learned, easy to take one out and replace it with another. Clean system structure, but maybe higher latency, maybe brittle, right? If C goes out, B no longer talks to D. The right-hand side is the exact opposite. Shorter path, shorter latency, more resilience, but harder to make a change. So interestingly, you have the same pieces put together differently, and you get the exact opposite characteristics. So that's part of zooming out, seeing this thing not as a bill of materials. Right? I often say it's like the menu, when you go to the restaurant, it doesn't say tomato, cheese, and wheat. It says pizza. Right? It shows like it calls you what the thing as a totality is. So think about the system as a whole and how the system as a whole behaves, not just A, B, C, D. Right? Your job as an architect is not to manage a bill of materials. Your job as an architect is to understand how all the pieces come together. I often say that you're the chef, not the guy or the girl getting the groceries. Right? You're not the one with the shopping list. You're the chef. You do the cooking. You put these things together because that gives it the important characteristics, and you do that by zooming out, by seeing things in its entirety. Right? And this is a classic example of seeing things zoomed in versus seeing things zoomed out. You can optimize globally. You talk about integration. You can look about how teams span. Right? Why is dev and ops being separate so poor? Each team is actually quite happy because developers only need to build software, and operations does only operations. Locally, it seems fine. But one level zoomed out, it's horrible, right? Because you have this whole throwing over the wall, slow feedback cycles, right? So these things that look good in the microcosm don't look good as soon as you zoom one level out, right? Remember our elevator, right, with the illusion in the middle layer, right? Each layer is happy, but the whole picture is not happy. So that's what the power of zooming in and zooming out is, to see the overall structure and see the issues that derive from that. So that leads us to another architect insight. Local optimization is natural. Each team will do a good job at what it's responsible for because they can control that, they can measure that, they will optimize that. But the sum of local optima is rarely or never a global optimum. So as an architect, you need to have this ability to zoom in and zoom out and see locally, but also see globally. Now, the world we're in, we already talked about this quite a few times, the world we're in is not simple, right? There's a lot of complexity. And I always remind people, the kind of applications we can build today, right, it's distributed, event-driven, asynchronous, scale-out, self-healing, auto-scaling. We can build pretty amazing stuff, but it isn't exactly simple, right? There's a lot of complexity. The best weapon you have against the complexity is models. I hinted at this with the sketches, right? I said a sketch is like a model. Models are very powerful because they shape your thinking. So graph I borrowed Dave Farley, he found this somewhere. A long time in history, right, some folks said the earth must be in the center of everything, so there should also be, the earth should be in the center of the universe, because obviously we are there and we're very important, right? It's called the geocentric, maybe self-centric, should be another word, right? It's like we believe we're in the center of everything. Now, if you believe in that model, the planets move in pretty strange patterns. And they make these like rapid turns and go back and forth. The sun is still okay, right? But all the other planets, they're like completely messed up. It's like, how can this be? Now, the question here is not figuring out how the planets can make these sharp turns. The question is, are you using the right model for your thinking, right? And it turns out, right, the sun is actually in the center of our solar system. That's why it's called solar system, right? And that model now clears up your thinking. It's like, yeah, totally, they go around the sun, okay, the ellipses, not circles, right? But it's an abstraction, but suddenly your world makes total sense. So what we often do as architects where we fail, we try to explain things in our model to people who have a different model, and that always goes wrong. And then the conclusion is, oh, they don't get it. Oh, they're not quite so smart. You know, they don't want to, and it's like, you know, all these funny arguments come. The reason is they use a different model. And unless you get the models to align, you have no argument. And I have many, many examples of this, right? So let's come back to our favorite sort of CI/CD continuous delivery, right? If you believe speed is valuable and you talk to a person who is very much cost-driven and sees the world in a static kind of cost optimization, you can talk about speed all day long. They will not find any value. It might go opposite, because when you say fast, they might believe error-prone, right? Oh, sloppy, quick and dirty, right? If you're quick, you're also dirty, right? If that is their mental model, and you say, hey, we can release 100 times a day, they're like, oh my God, that's going to be worse than, that's like worse than now, right? And you're all excited, and for them, this goes exactly the opposite direction. That's what happens if you have different mental models. So it's very important to get the models to align, and only then can you make your argument, right? So if you, let's pick this example, if you can articulate cost of delay, for example, right? That if it takes us 6 months to put software in production, how much development effort we do, this can cost us millions that we haven't released. Then you translate the time into money, and then you start transcending these mental models. So most of the time when people don't get what you're talking about is because they have a different model, and repeating your stuff 5 times over will not help. You need to understand the model they use and either express your things, like make a translation, or convince them to use a different model. There's many nice quotes, right, about models. The one is that people use a lot, right? All models are wrong because they're not reality, but some are useful. George Box, Clever Gentleman, not many people read the second sort of part of that paragraph or of that quote, where he also said that the simple and evocative models, those are the good ones because they have the most abstraction. Now, many models that we draw, so our architecture diagrams I just Googled in the beginning, they are models. But we like to draw these pictures with many, many boxes, these big tapestries, our database schema, our system architecture. Those are actually not the most powerful models because they don't abstract away so much. So the good models are simple. And this is a common fallacy I see. People say, oh, this is too simple. It's like, no, a good model is actually simple because it abstracts the most away and brings you clarity. And then, yeah, so Data and Reality, fairly old book, right? People say, the highways are not painted red. And the last time I went on a hike, I couldn't find the topographical lines, right? These are models, they're abstractions. And when somebody says, oh, but this model isn't reality, it's like, well, it isn't supposed to be. It's supposed to be a model, but it clarifies our thinking. It makes us smarter, right? It allows us to make better decisions. It raises our IQ. So these are not good models, right? Too many times when we draw an IT model, we try to draw reality. Every system should be on there. That seems nice, but it's not the most powerful model. The simpler models are more powerful. Now, how do you make a simpler model? There's a little bit of a catch here. Here we made this easy because we use a system we all know well. Let's go planet Earth, right? So the system here is planet Earth, and here's like 4 different models of planet Earth. Which one is the best model? Trick question, right? They're all good. It depends on the question that you're trying to answer. A model has only value if it helps you to answer a question. Otherwise, it's artwork. That is nice, but not an architect's work. So the question here might be, I want to go for a hike, right? Or I want to build a ski resort, or I want to build my house outside a flood zone. Aha, topographical map. Political map, elections, right? Driving, shortest distance between A and B. And this one is a population density map. That's great for folks who build distribution centers, right? Or railroads or transport networks, right? Very different questions, very different maps. Now, when somebody says, show me your architecture or draw me your architecture, which is obviously a model of the real architecture, right? Because the architecture isn't a picture. It's a valid question to say, what question are you looking to answer? Right? If you're asking me to draw a model of my architecture, it should answer a question. So it's valid for you to ask, well, which question do you have in mind? Because I have a different architecture model, a different lens to show you depending on the question that you have. So no tapestries. Models should abstract. Some people say, oh, we can't model this is because it's too uncertain. That's exactly the opposite. The more uncertainty you have, the more actually the models help you. And yes, without a question, you cannot pick the right model. And we come to the last one here, shades of gray. Our machines are binary. Our world of architecture is not binary. It's all trade-offs, right? And I posted about this. I'm on LinkedIn a lot. So one of my most popular posts here says, you spot the poor architects by speaking in extremes. So everything must be in a container. Oh no, everything should be on this technology. Everything should be, oh, always do serverless, always loosely coupled, right? Oh, everything must be event-driven. These always, never kind of people, those are not the good architects. It's not as easy. You don't need to memorize and regurgitate sort of one buzzword. That doesn't make you an architect. You need to understand the trade-offs and the sliding scale that you have. And again, I use this in my talk about lock-in and switching costs, where I say, really, this is not on or off. It's not like the lock opens and closes. This is a sliding scale. Well, how much is this liability you carry, right? Your switching cost times the likelihood that you have to switch. And how much do you invest now to bring this down? And what is the sum of the two is the total cost. And somewhere on the spectrum here is like being naive, risky business, doing nothing. Here's being overinsured, right? I invest, 100,000 pounds to reduce my 5,000 pound liability to a 2,000 pound liability. And in the middle is the sweet spot. This is a range. Money makes good ranges, but it's not the only range. This is a range that you can use. So getting out of this, I must be here because my switching cost must be lowest. Getting into a range allows you to have a much better discussion. It's a little bit like the dimensions, right? In this case, you get out of the binary, it must be on or off. You get into, this is a sliding scale, so your solution space expands, and that again raises the collective IQ. So hopefully there was a good start for the track and gave you some inspiration when you say next time, hey, I'm an architect or I work like an architect, what that actually means. You don't need to give them the whole lecture, but you can easily pick and choose some things and say, yes, that means I sell options, or I zoom in and zoom out. I like to use models, and I see shades of gray. So thank you for your attention. If you like this kind of stuff, luckily I don't live from selling books, but there's always things you can read up on and get more from, and I even have a few here right with me to give away. Thank you so much.